for some of you who have joined recently or who were not part of the previous few classes, just a quick summary to you all. We are doing two classes right now for this group of senior students. So we are doing SAT preparation and we are doing pre-calculus also. So some of the kids who are in this class for the first time, they are actually in the the pre-calculus class, and they are joining the SAT class as well. And same thing for the kids who were doing SAT prep before. You are all welcome to join the pre-calculus class. I know I don't talk about money with you guys, but just for letting you know that whoever is my existing student, they can join the pre-calculus class without any extra fee. So you don't have to worry about it. Just an option that you have. So, and the pre-calculus class happens at 7 p.m. on Wednesday. So whoever wants to join pre-calculus class, you are more than welcome to join. And we will continue like this, where Saturday, Sunday we'll do SAT preparation, and then Wednesday is a dedicated class for pre-calculus. All right. And Khan Academy happens to be our source of not just source of truth, but is a platform which gives us the guidance around what are the things that we need to cover as part of any class. So for pre-calculus also we'll follow what we have in Khan Academy, uh, considered in scope for pre-calculus. Now for the SAT prep, right, there are 13 units, as you all would know. I had requested in last few classes that I would want you guys to just go through the digital SAT prep on Khan Academy and see what are the topics within those 13 units that you would want me to focus on. Otherwise, no, Khan Academy has, the entire SAT course has a lot of things which are very simple coming from junior classes, and I would certainly not want to spend a lot of time on those easy concepts, so that we can effectively use the class. So I would request you all to go back to those that Khan Academy digital city prep part of the syllabus and see what are the topics that you would want me to cover in these classes, so that we can focus on the things that are important and needs amount of some amount of guidance from my side. Okay, so whoever has done that, I think I have received feedback from only few of you. I request you all to go back to Khan Academy and then send me the topics that would be that could be of interest for you, and so that I can keep picking it up for the upcoming classes. Now, for today's class, as you would have seen, I have sent a message saying what we are going to cover today. So today's main focus would be circle theorems. So we'll talk about circle theorems. We'll talk about the center angle. We'll talk about the area of the sector and things like that. And then there are 7 to 8 theorems that related to circle theorem that we'll try proving today. And Arya, you had given me one task explaining you system equations, so that also I have put in the plan. If you have time to go beyond circle theorems, we'll try picking up the system of equations, and that's an option for everybody. You guys can always reach out to me and tell me that they are the topic that you want me to cover on priority. Okay, are you all good to get started with circle theorem?
Yes, sir.
Okay, all right, and keep this class as interactive as possible, because otherwise either I will fall asleep or you might fall asleep. Okay, so stay awake and keep me awake by asking questions, by by participating in the class. All right, and whoever is comfortable, I would request you to turn on your video also, because that way I feel better. I mean, I feel like I'm connecting you guys with you guys better. All right. Okay. So circle theorems. What is a theorem in the first place? Anybody? You guys don't know what is theorem? Okay. Theorem is a word derived from theory. Okay. So theory is something that is something that we hear in different contexts, and then that relates to a concept which we all kind of agree to. Okay, so now when we say circle theorem, we are essentially talking about the theories or the concepts around circles. Now, again, nobody has the option to laugh at me when it comes to my drawing skills. Okay, my drawing skills are not great. Just bear with me. This is a circle. The main property that we know about circle is it has a center, and the outer side of this is called circumference. Everybody knows that. And the property is from the center to the circumference, anywhere you go, this distance is fixed, which is called radius. I know these might be sounding very kiddish, but that's the starting point. So I start from ground zero and keep going up. So we all know this circle has certain properties. It's round in shape. The center is equidistant from each place on the circumference. Now let's look at what are the things that we know about the circle. And stop me if I'm going fast or if I'm going in the wrong direction. So if there is a circle, the area of a circle is, anybody remembers how much is the area of a circle? The formula for area of circle? Yeah, go ahead, Peter.
Pi r squared.
Pi r squared. And when we say area, we are essentially talking about the shaded region in this, the entire space taken by this circle on the board. Yeah, where r is the radius and pi everybody knows. Pi is nothing but 22 by 7. Neil, Sarah, everybody with me?
Yes, sir.
Okay. I'll keep waking up everybody, okay? I know it's a post-lunch session, so you might fall sleepy. So it's my duty to keep you guys awake. So we know the area. Now, when we say perimeter, perimeter is nothing but the length of the entire boundary. So perimeter, you call it perimeter, you call it circumference, both the same thing. Perimeter equals 2 pi r. Everybody knows that. So far I've not taught you guys anything. I'm still wasting your time, and that's okay. Now, fun begins when we start talking about arc and sector of a circle. Can somebody tell me what do we mean by arc and sector of a circle? Conceptually, if you say, what do you mean by arc of a circle? Let's say if I have drawn a circle like this and I have just joined the center with the circumference at two places. This part is called the arc, the curve that you see, where two of the radius are kind of cutting this into pieces. This part is called the arc, and instead of area, we call this a sector. So basically, it's like when you take a piece of the circle out with the help of two radius, cutting the perimeter two places, and taking that piece out like a piece of a pie. The entire area here, the shaded area, is called the sector, and this is called the arc. The curve, the boundary of the curve. Is everybody with me so far? Do we call it a sector and arc, or we call something else that I'm missing here? Pin drop silence, not good. Ritika, is this correct so far?
So far, I think it's okay.
Okay.
That's the center.
Okay. Now let's start learning something. So far it was only a casual discussion. Let's try learning something. If I have a circle and I'm using two radius two radius are making 30-degree angle. Who all can tell me, and the radius is equal to, let's say, 5 centimeter. Now who can tell me the length of the smaller arc? Do you guys know how to find it out? Yep. Yeah, Ishwari, tell me.
Oh, I don't know.
Okay, that's fine. Now I'm just trying to get a sense of who all knows, and so that I will accordingly kind of yeah.
Or is it actually just like the degree of the angle, like is equal to?
The degree, I mean the angle here between the two radius is 30 degree. So we are trying to find out the length of the arc. What we know is this radius and the degree, the angle. Anybody has done this before? Chris, Dave, Arya, Heel, anybody? Yeah, Arya, you had raised your hand. Yeah.
I'm not sure how to do this, but is it the same measurement of the angle that's across from it?
No. Okay. So let's okay. I think I have bothered you guys enough. Let's get back to business. Now, this is something that we will be able to figure out or derive based on the property of the circle that we know. We know that when we talk about a circle, this is the center, and center is equidistant from each point on the perimeter. Okay, and then one more property of a circle that I did not call out was that the entire circle makes 360 degrees. Correct? This circle makes 360 degree around the center. Correct? Any and every circle. Yeah. Now, if I have to find out the arc, meaning this curve from here to here, now as we discussed just a few minutes ago, perimeter is nothing but the entire length of the boundary. Be it a circle, be it a rectangle, be it a triangle, be it a pentagon, any shape for that matter, the perimeter is nothing but the length of the boundary. So here in case of the circle, the length of the boundary is 2 pi r, which is the perimeter, which is 2 pi r. Now, how you have to look at it is, if I am covering the entire 360 degree, I am making this much. And so if I am covering the entire 360 degree, this is equal to 2 pi r, meaning the whole perimeter. I am talking about only 30 degree, meaning if I am talking about 1 degree, if the angle is so small, 1 degree, the length of the perimeter, the length of the arc will be less, which will be 2 pi r divided by 360. Correct? So if I am talking about 30 degrees, meaning this piece, that will be 30 times of what it was for 1 degree. So 2 pi r multiplied by 30 divided by 360. Again, look at it. If look at this like a pizza, right? This is one slice of the pizza. If you had the entire pizza with you, that would have been 2 pi r, the perimeter. Now, since I have only a piece of the pizza, how big the piece is, that depends on how much is the angle. If 360 degree, the entire pizza, 2 pi r. If 10 degree, a portion of it. How much? If 360 degree was taken into account, the whole pizza was picked up, that was 2 pi r, the entire perimeter. Now we are talking about 1, if it's 1 degree, then how much? 1 degree will be whatever is the value for 360, you have to divide by 360. So 2 pi r by 360. If I am talking about 30 degrees, then this will be the length of the or portion of the perimeter that I am talking about, which is nothing but the arc. So now you do tic-tac-toe here and you get what you want to get. So it becomes pi r divided by 60. So 30 into 260 divided by, so now pi is 22 by 7. your r is 5 centimeter, divide by 60, and then you can do the calculation. Did I explain it okay? Or is there any doubt so far? Okay.
Yes, sir.
So always visualize this as a, if you're talking about circle theorem, your circle is nothing but a pizza actually. See, we don't deal with circle as a circle. Circle comes in the form of a wheel of your car, the pizza that you see around you. I mean the pizza that you enjoy, and then anything that is round in shape, like the bulb in the classroom, right? I mean you cannot see it. It's round in shape again. So those are the practical things that we see around us. So you can relate it that way. Now, I'm not sure if I was able to explain you guys fine or not. And the only way I can ensure that is by doing few sums. Now, I explain you the arc part. Now, let me trick you guys to solve this problem for sector, which is nothing but the area or the size of the pizza basically, size of the slice of the pizza. If this angle is 45 degree and radius is 10 centimeter, tell me what is the area of the sector of the circle. Can you relate it with what we just learned? Again, I'm just repeating myself. When we looked at the circle, we talked about the arc. Arc is nothing but the perimeter. And we were talking about just a part of the perimeter. How big that part is, that depends on how big the angle is. Right? So the entire perimeter is comprising of 360 degrees. We were talking about 30 degrees there. Here we are talking about 45 degrees. So again, how big the area of the sector would be a function of how big the angle is. Right? Now I want you guys to find out, you all know the area of a circle and I have given you the angle. Can somebody tell me what will be the area of this sector of the circle? Or at least give me an approach, how would you calculate it? You guys are very quiet today. Yes, Dev.
I think the way I would calculate is we know that total degree of the circle is 360, and we know it's 45, so we could put 45 over 360, and then we know that area of the circle is pi r squared.
Yes.
So we could multiply that by pi r squared.
Yes, spot on with the approach. Ritika, were you saying the same thing?
Yes, I was going to say the same thing.
Oh, wonderful. So it's very simple. You have to always visualize what we are trying to do. Only thing that you have to remember is the terms. When somebody says arc, we know we are talking about the boundary. When somebody talks about the sector, we are talking about the area. And then always remember, this is making 360 degrees. Okay. So this is the area and sector and arc part of it. So let's do one sum quickly before we jump onto the circle theorem where it gets a little more interesting. Okay, and I would want everybody to try, and I will give you guys 5 minutes to solve this, and then you don't have to raise your hand. I will randomly call the name to see if everybody is able to try or at least approach in the right direction. Okay, because I'm not biased. I have to make sure that I'm taking care of each one of you. So I can ask question to anybody to see if you are able to solve it. And if you're not able to solve it, that's perfectly fine. I just need to know that you're not able to solve it so that I can guide you to get it solved. Now, this is a circle. And the center angle, I'm introducing a new term, center angle. So the angle that I was talking about, that is called center angle. Okay. So center angle is 120 degrees, and the radius is 8 centimeters, or let's say 21 centimeters. Can you find out the area of the sector which is made by the center angle and the arc both? And it is pretty straightforward. You guys know it. I just want you to get your hands dirty. So yeah, get going. I'm repeating the question again. This is a circle where the center angle is 120 degree, meaning that the two radius which is making angle on the center, that is 120 degrees. Find out the arc and the area of the sector. And you have only 5 minutes. Your time starts now. And remember, I will call out the names. So everybody has to try it.
What are we trying to find?
Yes, Neil?
What are we trying to find?
We are trying to find out the arc and the sector area both.
Okay.
The same way like what we were doing separately, I mean while I was explaining it to you guys. So I want you guys to solve it now and just try solving it. It's fine. If you go down, it's fine. Going down is not a crime. That's okay. Okay. So, alright. So let me not proceed further. Whoever is able to solve, you guys can continue solving it, and let me explain this to some of you who are not able to understand this. So, very simple. We all know what is a circle, right? No problem with that. Now, the circle makes a total angle of 360 degrees around its center, correct? If I have, let's say, an angle of 30 degree, if let's say these two are two radius of the same size, if I make this a complete circle, this total angle is 360 degrees, right? And we know what is the area for a circle. We know what is the perimeter of a circle. What we are trying to do here is, if I'm taking a part of the circle, meaning instead of taking the entire 360 degrees, if I take a piece of the circle or a piece of a pizza which is circular in shape, if I'm talking about only 120 degree, this is center angle, meaning the two radius taking 120 degree at the center. We are trying to find out the area of the sector, this part, how big the slice of the pizza is, and what is the arc, length of the arc, meaning this angle is making an arc on the perimeter, how big that arc is. So we are trying to find both. So when I was explaining, so Aryan, did you get that part? Yeah. So if you relate, so basically it's very simple, okay? So now whoever is trying this, you all can stop because anyways I'm going to solve it now. So what we were trying to do was find out the size of the pizza slice and the length of the boundary of the pizza, the arc. Now, if we would have started from here, traveled all the way to here, that would have been the complete circumference of the perimeter of the circle. That would have been 2 pi r, the complete 2 pi r. But we are starting from here. We were supposed to go all the way till here, but we stopped in between, halfway through. We just stopped here when it made 120 degrees. Meaning, we are talking about part of the perimeter. How much of the perimeter? Let's look at the arc. The arc is not the complete perimeter, it's some part of it. How much it is? If it would have made the complete 360 degrees, if it would have traveled the entire 360 degrees of the circle, it would have made 360, it would have covered the entire perimeter. So 360 degree would have been entire perimeter, which is 2 pi r. We said no, we did not cover the entire piece. We covered only 120. So let's figure out. 360 is equal to 2 pi r, meaning 360 degree makes the complete perimeter. How much 1 degree will make? Obviously, divide that by 360, right? If If you can buy two samosas for $5, how much you get one samosa for? 5 by 2, right? Same thing. Yeah. Now 120. If 1 degree makes this much, how much 120 will make? You have to just multiply it by 120. Right? Yeah. This gives you the, now when you solve it, you will put the value of R, which is 21 centimeters here, and then you do the calculation. Yeah. Aryan, this part clear? Yeah, again, I'm calling out Aryan's name not because I'm trying to put Aryan on the spot, just because Aryan wanted me to explain, that's why I'm calling your name. But is this part clear, Aryan?
Yes, sir.
Okay. Now, same way, and I'm not doing the calculation right now because that I believe you all can do. Same way, if I have to find out the area of this sector or the size of the pizza, same thing. If this would have covered 360 degree, meaning the entire circle, that would have been the area, the entire pizza, which was pi r square. We are talking about 120 degree only. Okay, so how, if it was 1 degree, it would have been pi r square divided by 360. If it is 120, so this will be multiple of this. One banana comes for half a dollar. 120 banana will come half multiplied by 120. Same thing. By 360 and multiply this by 120. Let's solve it. Pi into r square. R is nothing but 21 centimeters. So 21 into 21 into 120 divided by 360. 120, 360. Now you have pi is nothing but 22 by 7 multiplied by 21 multiplied by 21 divided by 3. 7 3 are 21 and 3 and 3 gone. So 22 into 21, 461. Yeah. I think it's 461. Yeah. I was probably rushing for it. If I'm wrong, don't care about it. You multiply by yourself and you will probably get it. 462, I think. Yeah. Yeah. So this is exactly what we all were supposed to do. This is the basic part of it. Now comes the most interesting one, which is nothing but the circle theorems. Are you all clear so far? What is sector, area of a sector? What is the arc of a circle? What is center angle? And how do you calculate, derive area of a sector or arc of a circle? You all can do it, right?
Yes, sir.
Everybody, Ananya, are you comfortable?
Yes, sir. Yeah.
Yeah. So see, again, I'm randomly calling out names, not to put anybody on the spot, just to get that confidence that yes, everybody in the class is with me. Dave, Chris, everybody with me, right?
Yes, sir.
Okay.
Yeah.
Wonderful.
Yes, sir.
Wonderful. Now comes the yeah.
Question.
Yep.
So did you say like the two different, like the area is the pi r square and the perimeter is 2 pi r? So when we want to find the area, we use that. And we want to find the arc, we use the perimeter.
Yes. So when I'm saying arc, I'm talking about portion of the perimeter. When I'm saying sector area, I'm talking about portion of the area of a circle. So now you can relate it. Now this is my circle. We know my total area. When I say area, meaning the total area, everything inside this, right? Is pi r
So
square.
we're gonna plug like a for 360.
Yeah. So basically, depending on, so first thing first is the entire area is pi r square, and my entire perimeter from here to here, it is 2 pi r. Now we know that this is making total 360 degree angle. If somebody says find out the length of the arc when the center angle is 20 degree, meaning the angle made on the center is 20 degree. Find out the length of the arc and the area. Now you know that this is not the complete circle, this is part of the circle, right? How big the part is, that is how big the part is this. If it was 360, this would have been 1, the complete circle. It is 20 degree only. So 20 by 360, and then you multiply it with area to get the sector area, multiply it with the perimeter to get the arc.
Oh, okay.
Yeah.
So the first. Oh, okay.
No, it's okay. Go ahead. Ask as many questions till you are comfortable.
Look, I get the area part though. For the perimeter, I'm confused.
No, so see again, perimeter is same thing. If you look at perimeter, what do you mean by perimeter? Perimeter is nothing but the length of the string that goes from here to here, correct?
Yeah.
Here, when you say arc, we are only talking about this curve, this part. And this part, how big is this part? Is a function of how big or small the angle is. See, this arc is becoming bigger when you increase the angle, right?
Yeah.
Right? If you cover the entire circle, meaning from here to here, then this is the total perimeter. We are talking about only part of it. And how big that part is a function of the angle. So same thing applies in case of arc. How big the arc is? This angle divided by 360. Area, this angle divided by 360. You just have to multiply for arc. You have to multiply with this guy. For area, you have to multiply with this guy. Yeah.
Okay. Thank you.
No problem. Everybody with me so far, right?
Yes, sir.
Dhanushri, you have been quiet, but I believe you are with me as well. Yeah?
Yes, sir.
Okay, alright. Let's move on. Now comes the theorems of circle. This was only I would not call it a theorem. I will call it probably some of the properties of circle. That's what we were dealing with so far. Now let's talk about the theorem of circles. I don't know who all got a chance to look at what those theorems are. I had sent you a picture which has okay. So let's look at these are 8 theorems of circles. We'll try proving those using different techniques. Okay. Okay. You all know about the theorem of congruence for the triangles, correct? Everybody knows those. If there are 2 triangles which are congruent, there are 4 ways you can prove them. Congruent again. When we say congruent, meaning the 2 shapes are exactly the same. They have each and every matching property, and they have same area, same angle, everything, right? So or they can literally overlay each other.